So today we are going to discuss about auto vacuum in Postgres. So what exactly mean by auto vacuum? We are going to see what is the difference between vacuum and auto vacuum, and also we are going to see what are the different operations that we can perform through vacuum and what is the use of the vacuum operation in Postgres. These are all the things that we are going to discuss, and this is very important, and you can expect at least 2 interview questions from this topic together. Okay. So the today's topic is vacuuming. 1 minute, I think it's not working. Okay. So today's topic is auto vacuum. So before discussing about this auto vacuuming, so we are going to discuss, what exactly mean by MVCC in Postgres. MVCC. What exactly mean by MVCC is MVCC refers to multi-version concurrency control. Multi-version concurrency control. What exactly mean by this multi-version concurrency control? So multi-version concurrency control talks about which user has to see what version of data. Okay, multi-version concurrency control talks about which user has to see what version of data. Is it MVCC or multi-version concurrency control is limited to Postgres? No, it is not limited to Postgres. You can take any of the RDBMS, you will be seeing this multi-version concurrency control. Okay, so you will be seeing this multi-version concurrency control. So whatever the RDBMS that you are going to develop, or whatever the RDBMS that you are going to use, it has to follow a basic properties called ACID. What exactly mean by ACID? So every database that you are going to build, it has to follow the ACID properties, which means like atomicity, consistency, integrity, and durability. These properties we call it as a ACID properties. So how we are going to achieve the multi-version concurrency control is, let's say I have a user called H1. Okay, I have a 1 minute. I have a user called H1 who is connected to the Postgres database. Okay, who is connected to the Postgres database at 9 a.m. and he fired a query called select star from EMP. So let's say, so before discussing about, let's talk about, or let's define the structure of a EMP table. The structure of a EMP table would be, this is the EMP table at 9 a.m. So employee number, employee name, salary, and department number. So this is the employee table that we have defined. Okay, the employee number would be 1, employee name is A, salary is 100, and department number is 10. Okay, employee number is 2, employee name is B, salary is 200, and department number is 20. And now employee number 3, employee name C, this is 300, and department number is 30. This is the EMP table at 9 a.m. So what happened, right? Let's say the user H1 has connected to the Postgres database and he fired a query at 9 a.m. So, and the expected completion of the query execution is, so which means the user is going to get the output at 9:30 a.m. So select star from EMP is going to take how much time? Select star from EMP is going to take 30 minutes of time. Okay, it is the execution time of the select star from EMP query is 30 minutes. So now, so at what time H1 is going to get the response? At 9:30 H1 is going to get the response. Okay, so another user called H2 who connected to the same Postgres database and he performed one update operation. At what time he connected is at 9:15 a.m. He connected to the Postgres database and he performed an update operation like update EMP set sal equal to sal plus 100 where department number equal to 20. So the employees, whoever belongs to department number 20, their salary is going to get increased by 100 rupees from the existing salary. Okay, their salary is going to get increased by 100 rupees from the existing salary. Okay, so let's say this update operation is going to take 5 minutes. So by what time, okay, by what time user H2 will get the response? User H2 will get the response by 9:20. By 9:20, user H2 will get the response. So how much time update operation has taken? Update operation has taken only 5 minutes. Okay, according to the acid properties of the database, user H1, okay, according to the acid properties of the database, user H1 who started his query at 9 a.m., he should get, or he should see the data as of 9 a.m. What does it mean by as of 9 a.m.? Whatever the data that is available at 9 a.m., he should be seeing that data only. Whatever the intermediate operations or intermediate updates that are happened, that should not be visible to the H1 user, because as H1 user has started at 9 a.m., he should get the data as of 9 a.m. and the intermediate operation should be not visible to the H1 user. This is where the multi-version concurrency control comes into picture. So now let me go to the next slide. So at 9 a.m., this is the employee table. So how Postgres is going to maintain this, how the user H1 is going to get the data as of 9 a.m. is using a concept of MVCC, multi-version concurrency control. As how multi-version concurrency control is achieved in Postgres is using a concept of dead tuple. Okay, how we are going to achieve the multi-version concurrency control? Multi-version concurrency control in Postgres is achieved using a concept of dead tuple. What exactly mean by dead tuple? In Postgres, technically an update operation, okay, in Postgres technically an update operation is nothing but insert plus delete. Technically in Postgres, an update operation is nothing but what? An insert plus delete, where a new row will be inserted with the updated value and old row will be marked as a dead. So the user H1 will get the data from which tuple? The user H1 will get the data from the dead tuple, and this dead tuple is needed till when? This dead tuple is needed till 9:30. After 9:30, if the H1 again queries the select star from EMP, will he be able to get the new data or old data? He should be getting the data, new data only. So after 9:30, this dead tuple is not required, and vacuum is an operation to remove the dead tuple. So what is vacuum? Vacuum is an operation to remove the dead tuples. So how this table will be how this table will be rewritten after 9:20 a.m. Okay, EMP table at 9:20. 9:20 means the update operation has been completed. How this table will be rewritten, let me take this EMP table again. So employee number, employee name, salary, and department number. Okay, employee number is 1, employee name is A, salary is 100, and department number is 10. Employee number 2. So an update operation is nothing but what? Insert plus delete. So a new row will be inserted with the updated value 200 plus 100, 300, and department number is 20, and old row will be marked as a dead. Again to B 220 and 3 C 330. So this row we call it as a dead row. So from the H1 user will get the data from which version, which row? Dead row. That's how it is going to maintain the multi-version concurrency control. So are you clear about the dead tuple, or do you have any doubts? I take it as an S. So this is how vacuum operation is used to remove the dead tuple. So when can we remove the dead tuple? So once after 9:30, the dead tuple is not required. So because after 9:30 the session is going to get completed. If again the same user queries the table, he should get the data uh, latest data, right? So vacuum is an operation to remove these dead tuples. So how you will perform vacuum? So why do we need to perform the vacuum? Which means why do we need to remove the dead tuples? Right. So why do we need to remove the dead tuples? If you are not going to remove the dead tuples, the number of dead tuples that are accumulated in the table increases. When the number of dead tuples increases, the time it will take to scan the table increases. When the time it will take to scan the table increases, performance of a query will get decreases. That is the reason why you need to perform a vacuum operation to remove the dead tuples. In Postgres, there are two different operations in Postgres. One is a vacuum and second one is a analyze. 1 minute here. 1 minute. What is it? Yeah. So one is a vacuum and
Yeah, hurry 1 minute.
yeah.
So whenever user querying select query, so it will be locking for that particular table or it will lock entire. Uh,
Why it will lock the particular table? It won't lock, right?
no, locking means um, okay, because it is showing old data only, right? Till that. So
So
if
you are from a Oracle background, right?
yeah,
So you do you know how the undo table space works?
yes,
Yeah, that is
that
exactly same way. In place of undo, they have introduced a concept of dead tuples. So in Oracle, if you update operation, this old data will be stored. Our old data, our past image data is going to stored where in the undo table space, right?
yes, old data will
So
show in undo.
likewise, this old row is going to get stored in the dead tuple.
Okay, so there is no locking like that, right? Here, okay.
No locking. Okay, clear?
Yes.
Yeah, you'll get more clarity in a while. Okay, so in Postgres there are two maintenance operations are called. One is a vacuum and second one is a analyze. First we'll discuss about the vacuum, then we are going to discuss about the analyze. This is very important. Okay, so vacuum is an operation to remove what? Dead tuples, right? So how you will perform the vacuum? We can perform the vacuum at a table level and we can perform the vacuum at database level. Okay, so we can perform the vacuum at a table level and we can perform the vacuum at a database level. Let's say if you want to run a vacuum operation for a table, how can you perform? Right, vacuum space. 1 minute here. This is not working, I guess. Sorry. So vacuum space schema name dot table name. This is how you will perform the vacuum operation at a table. So if you want to perform a vacuum at a database level, if you want to perform a vacuum operation at a database level, then just connect to the database on which you want to run the vacuum operation. So let's say if you want to run a vacuum operation on the CRDS database, just come to the database and run vacuum. This is how you can perform the vacuum operation. And so if you want to, like if you want to see what is happening while running vacuum, right? So you can use a verbose option. So vacuum space verbose space vacuum verbose. So this will perform the vacuum operation at a database level and it prints the output as well. So if you want to perform the vacuum operation at a table level, vacuum space verbose schema name dot table name. This is how you will perform the vacuum operation. Now let's go and check how can we perform this. So let me connect to the Postgres database. And how can we list the databases? /l is a command to list the databases. Now let me connect to the CRDS database. CRDS. How can we list the schemas that are available in the particular database /dn? Let me check. Do we have any tables in sch2 dot star? No. Which DB we have used mostly? I think EDW. Let me connect to the EDW database. /dn. Okay. /dt edw underscore app dot star. I have 3 tables right now. So how can you if someone asks you to perform the vacuum operation, so then how you will perform vacuum space schema name dot table name edw underscore app dot clean. Okay, if you want to print the output vacuum space verbose space edw underscore app dot, I will take one more table test. So this is how it will print the output. So okay, this is how. So if you want to run the vacuum operation at database level, so I connected to the database edw and vacuum verbose. This will run the vacuum operation on all the tables which are available in the schemas that are there in the edw database. Okay, this is how you will run the vacuum operation. So as I said, so vacuum is going to remove the dead tuples. How do you check the dead tuples that are there in the particular table? What is the data dictionary that is used to check the dead tuples that are there in the data that are there in the particular table? So there is a data dictionary called pg underscore stat underscore all underscore tables. Pg underscore stat underscore all underscore tables are both are same. Pg underscore stat underscore user underscore tables. These any of them you can use. These are the data dictionaries through which you can get the list of dead tuples that are available or that are there for a particular table. So now let me try to query this table. So /d space pg underscore stat underscore all underscore tables. So select schema name comma rel name comma, okay, n underscore live underscore tup talks about the number of rows, n underscore dead underscore tup talks about the number of dead tuples from pg underscore stat underscore all underscore tables where schema name equal to edw underscore app. Okay, see, each table contains two live tuples and each table contains how many dead tuples? 0 dead tuples. Okay, so now what I'll try to do, right, I'll try to create one table and I'll try to generate some dead tuples. Okay, so create table edw underscore app dot emp employee name varchar of 10 comma employee number numeric comma sal numeric comma department number numeric. Okay, now let me try to insert data. Insert into edw underscore app dot emp values employee name Hari comma employee number is 1 comma salary is 100 comma department number is 10. Okay, I have inserted some data. Now likewise, let me take this and let me try to generate statements. Again, I'll insert the same data. Control A, control C. Okay, now what I'll do, I'll try to change some of them. Control H, 10 will be replaced with 20. Just I'm trying to generate. Okay, everything got changed. Huh? Okay, let me make something as 10. Okay, so let me try to insert this data. attention. Now select star from edw underscore app dot emp. So I have it. Now what I'm trying to do, I'm trying to delete the data. Before deleting the data, let me try to get the dead tuples count for this table. Okay, let me try to get the dead tuples count for this table. How can we get this? Select schema name, relation name, live tuples, dead tuples from pgstat all tables where schema name equal to edw underscore app. So for the emp table, how many number of live tuples are there? 23 live tuples are there. Now let me delete something. Delete from edw underscore app dot emp where department number equal to 10. So whoever belongs to department number 10, I'm going to delete that. So I have deleted that. Now let me try to check the dead tuples count. See how many dead tuples are there? If you are able to see, there are 5 dead tuples are there. So as I said, vacuum is an operation to remove the dead tuples. Vacuum space. How can we check schema name? Vacuum space verbose space schema name dot table edw underscore app dot emp. I ran this vacuum operation. Now let me go and check how many number of dead tuples still we have. Do we have any dead tuples now? No, because we have run the vacuum operation which has removed. See, had identified the 5 dead items and removed. Okay, those dead tuples got removed. So this is how the vacuum operation works on Postgres. And one more thing, is there any case where though you run the vacuum operation, it is not going to remove the dead tuples? Yes. Let's say the user h1 who is running the query at 9 a.m. is going to get the data by 9:30, right? So he is going to get the data by 9:30. At 9:15 someone has performed an update operation which is going to take 5 minutes. So by 9:20 you are going to get the data back. Okay, but in between at 9:25, okay, in between at 9:25, let's say you perform the vacuum operation on the emp table. Okay, in between at 9:25 you perform the vacuum operation on the emp table. But so technically when you perform the vacuum operation, what has to happen? Technically when you perform a vacuum operation, it has to remove the dead tuples, but so those dead tuples are still in need of by user h1 because the execution is going to get completed by 9:30, but at 9:25 only you started running the vacuum operation. Though you run the vacuum operation, the operation will be successful, but it is not going to remove the dead tuples because these dead tuples are still needed by user h1. So the one of the interview question would be, so running a vacuum operation will always remove the dead tuples? The answer is no, because if any long running transactions are in need of those dead tuples, it is not going to it is not going to remove the dead tuples, but the vacuum operation will not fail. Vacuum operation will be successful, but it's not going to remove the dead tuples. So this is about the vacuum operation. And one more operation that we are going to discuss is a vacuum full. This is also one of the very important interview question. What is the difference between vacuum and vacuum full? So vacuum is going to remove the dead tuples. Likewise, vacuum full also going to remove the dead tuples. It is also going to remove the dead tuples. Okay, so when you perform the vacuum operations, the dead tuples will be removed, and whenever you remove something, the space will be released, right? In the vacuum operation, okay, in the vacuum operation, whatever the space will be released at the table level, space will be released. Space will be released at table level and used for the future inserts on the same table. Okay, so whatever space that is released, that will be used for the that is released at the table level, and it will be used for the future inserts on the same table. So when you perform the vacuum full operation, space will be released back to the operating system. Space will be released back to the operating system. Oh yes. So and third point is vacuum full. Vacuum full is going to hold a exclusive lock. Okay, vacuum full is going to hold an exclusive lock on the table whenever you are going to run the vacuum full operation. And so if someone asks you to perform the vacuum full operation, we need a downtime. Okay, we need a downtime. So for the vacuum operation is a normal one, it doesn't need any downtime. Okay, it doesn't need any downtime. So why vacuum full needs a downtime? Because it is going to acquire an exclusive lock on the table, so it needs a downtime. So whenever you are running the vacuum full operation, if someone is trying to access the same table, then we would be seeing some blocking sessions in the database. So the major difference is vacuum full needs a downtime, vacuum doesn't need a downtime. The whatever the space that is released back, it will be released back to the operating system, whereas whatever the space that is released back, that will be released at the table level, and it will be used for the future inserts on the same table. So this is the difference between vacuum and vacuum full. How you will run the vacuum full? There is no difference. Okay, vacuum full space schema name dot table name. So this we call it as a maintenance operation, and we will perform this vacuum full operation during the non-business hours or weekends only, because at that time we will request the application team to stop the application, and we will perform this maintenance activity. Okay, otherwise if you want to run the vacuum operation at a particular database, just connect to the database and vacuum full verbose. Vacuum full verbose. Let me go to a database /c training. What is the size of this database? How can we check the size of a database? /l plus, right? 780. Do we have any database with more size? We should have something, right? Yeah, this one. What is this? DMS /c DMS. Okay. So /l plus DMS. What is the size of the database? The size of the database is uh, almost like 3.3 GB, right? Now let me try to check what are the schemas. Okay, these are the schemas. Now let me check /dt demo.star. In which schema we have the data? /dt public.star. I think this is having select count of star from demo.app 0, select count of star from demo.test somewhere we have this is the table. We have more data. Now what I'm trying to do, right? Observe carefully /l plus DMS. Okay, so what I'm trying to do, delete from demo dot test. I'm going to delete the data. What is this? Demo. Delete from demo dot test. It will take some time because this table is very huge. Let me open one more session. Okay, we have lot of available space, that's fine. So let it run. It will take lot of time because it contains crores and crores of data. Let it gets completed. So how can we check? Meanwhile, what we can check, how can we check list of queries that are running in the database is, we have a data dictionary called pg underscore stat underscore activity. If you remember when we were discussing about, like the stats collector, so we have discussed that the stats collector is a process which is going to monitor the queries that are being running against the database, right? So how can we check? Select dat name refers to database name, use name refers to username, and query refers to query which is running from pg underscore stat underscore activity, where state equal to, state means the query state or session state equal to active. We are going to list the active sessions that are running in the database. What is the active session? Delete from demo.txt is the active session, still it is running in the database. From how much time it is running, how can we check? Select dat name comma username comma query comma, there is a one more column called query underscore start. So where is that? Query underscore start. Now minus, now is the timestamp, now minus query underscore start will give you the from when it is going to run, from pg start activity where state equal to active. See, this query is running from 2 minutes. If you want to check the wait event, right? So if you want to check the wait event, you can add one more column, space runtime, comma. If you want to check the wait events, what is the wait event? Wait event type, comma, wait event type, comma, wait event from pg stat activity where state equal to active. So we are going to get the only active sessions. Do you see any wait events? There are no wait events. Okay, it is running from last 2 minutes. It will take some time for sure. Three minutes. Let it run. I'm going to see you something. Meanwhile, let me check the space. Okay, user is 11 GB. Oh my goodness. Okay, this is going to fail. So what I'll do, right? I'll remove the archives. PG archive. Sorry, cd/u02 ls. cd space archives ls. Nothing is there. So let me go to the data directory. u02 Postgres data directory. cd space log ls-ltr. If archive log mode is enabled and if the location is not available now, then it is not going to remove the then it is not going to remove the val files, right? So let me create this location /u02 archive. You got my point, right? This we have already discussed, right? So if the archive location is not available, then it is going to do what? Then it is going to retain the val files in the pg_val location only. So now let me try to create. Okay, now let me try. I try to create the archive location. -chown-r Postgres Postgres. So this archiving location is not available. That is the reason why it is going to keep all the val files in the pg_val location, and that is the reason why the space is going to get occupied. Okay, now the moment you create the archive location, see, archives are getting copied. So just what I'll do, I'll try to remove these archives. rm-rf See, now the space will come back to the normal. rm-rf star. So once it got copied, no, what happens? The space will be released back. We'll see, because pg_val is going to overwrite, and then the space will be released back. Okay, just I'm removing the val files from the archive files from the archive location. Okay, this we have already seen during the archive log management. Still it is running. Yes, deleted. How many rows? 6 crores 71 lakh. Oh. Yeah, 6 crores 71 lakhs 8,864 records got deleted. Now let me try to check the space, the size of a database. How can you check the size of a database? /l+dms. So 3348 MB only. Now let me try to run the vacuum operation. Vacuum space verbose space schema. What is the schema name? Demo dot. What is the table name? Test. I'm trying to run the vacuum operation. Okay, vacuum operation. So will take some sorry, will take some time because it is a big table. Okay, so observe the points carefully, because we, so after deleting also, what is the size of the database? The size, do you see any difference in the size of the database? No. 3348 MB before delete, 3348 MB after delete as well. So now we are trying to run the vacuum operation on the table on which we have deleted the huge number of rows, which is like 6 core rows. Again, it will take some time. So now if you want to find out the queries that are running in the database, as I said, select username comma PID comma query from pg underscore stat underscore activity where state equal to active. Vacuum operation is running. So this is the PID, is the process ID. Okay. Yeah, vacuum operation is completed. Now /l plus dms. Oh, generally, so when you perform the vacuum operation, it should not release the space back to the operating system. Let me check whether the space is released back to the operating system. Okay, 17 GB is available. So now what I'll do, right? Generally, what happens is when, so here it happened, but generally when you perform the vacuum operation, it will not remove the space back to the operating system. So now what I'll do, I'll try to run the vacuum full, vacuum space full on the database level. Okay, now /l plus dms. See, some space got released back to the operating system. Here, ideally, this data, okay, this should not change. The DMS size should be 3 GB only, but somehow the space is released back. So, but generally, vacuum operation will not remove the space back to the operating system, whereas vacuum full is going to remove the space back to the operating system. Whatever the bloating is there, okay, whatever the bloating is there, or we call it as a fragmentation, that fragmentation will be removed and space will be released back to the operating system when you perform the vacuum full operation. But somehow the space is released back here, that I need to check. I'll check and let you know why. And so this is about the vacuum and vacuum full. So the next operation that we are going to see is, we are going to discuss about an analyze operation in Postgres. What is analyze? Analyze also you can perform at a table level, and analyze you can also perform at a database level. So if you want to perform analyze at a table level, then analyze space schema name dot table name, or if you want to run it at a database level, simply analyze. So what exactly mean by this analyze is going to gather the statistics, stats. So in Oracle, dbms underscore gather stats is there, right? Likewise, analyze is going to work. So whenever you create any index on the table, or whenever you delete some index on the table, there must be a way to let the optimizer know that so and so index has been created and so index has been deleted, kind of things. Optimizer should know about to generate the best execution plan. For that, analyze is going to gather the statistics, and these stats are used by the optimizer to create the better execution plans. Okay, so how can you run the analyze at a table level? Analyze space schema name dot table name. Okay, if you want to run a analyze at a database level, analyze. If you want to use a verbose, you can use verbose as well. Okay, and you can run the vacuum and analyze operations together. How can you do? Vacuum space vacuum verbose analyze. So this run the vacuum operation, then it will run the analyze operation on the database level. If you want to run the vacuum and verbose vacuum and analyze at a table level, vacuum verbose analyze schema name dot table name. So first it will run the vacuum operation on the table, and then it is going to perform the analyze operation on the table. This is how you can perform the vacuum and analyze operations in a Postgres. So with this knowledge in mind, So what are the discussion that we have gone through so far? So we have discussed about the vacuum, we have discussed about the analyze, and we have also discussed about the purpose of the vacuum and purpose of the analyze. So the purpose of the vacuum is to remove the dead tuples. So how dead tuples are going to get created because of the multiversion concurrency control, right? So now we are going to discuss about an operation called auto vacuum. Auto vacuum. So what is auto vacuum in Postgres? Okay, so whatever the discussion that we have gone through so far, we as a person or a DBA, we are going to run the vacuum and analyze operations manually. Okay, so it is very difficult for us to run the vacuum operation every day on a table or every day on a database, right? So to avoid these situations, Postgres has introduced a concept called auto vacuuming. So what auto vacuum refers to, right? Auto vacuum is the feature in Postgres which has automated the operations of vacuum and analyze. So which has automated the operations of vacuum and analyze. So auto vacuum contains two operations. One is a auto vacuum and second one is a auto analyze. In Postgres, there is a special feature called auto vacuum, which has automated the process of vacuum and analyze operations. This we call it as a auto vacuum and auto analyze. So what happens, right? Whenever a table, if you remember when we were discussing about the auto vacuum work memory, auto vacuum worker is a process which is responsible for that. That is the reason why understanding of the architecture is very important. Auto vacuum worker is a process which is responsible for performing this auto vacuum and auto analyze. Auto vacuum worker is a process which is responsible for performing this auto vacuum and auto analyze operations, and each auto vacuum worker will be assigned with some amount of memory which is called auto vacuum underscore work underscore mem to perform these operations. And auto vacuum launcher is a mastered process which is responsible for performing this auto vacuum and auto analyze operations. So how and when this auto vacuum operations are going to happen? So whenever the table reaches a certain threshold, then auto vacuum is going to run the vacuum and analyze operations. What is the threshold? So for that there is a formula: auto vacuum vacuum threshold for a table equal to auto vacuum threshold for a table equal to number of tuples into auto vacuum scale factor. Auto vacuum scale factor plus auto vacuum threshold. Auto vacuum threshold. So let's say I have a EMP table with 1000 number of rows, then the formula will be number of tuples means number of rows 1000 into, this is a parameter which is having a 0.2 as the value. Okay, auto vacuum scale factor is a parameter, so which is a 0.2, and auto vacuum threshold is also a parameter. The value is 50. If you want to change, you can change them, but generally we don't prefer to change. Okay, now 1000 into 0.2 means 200 plus 50. Whenever there are 250 number of dead tuples are there, then the auto vacuum operation will be triggered automatically to remove the dead tuples. Okay, whenever the table reaches, let's say if the table has 1000 rows and there are 250 number of dead tuples are there, then the Postgres is going to run the vacuum operation automatically on the table. So when the analyze operation is going to happen, auto vacuum, in place of vacuum just keep analyze. Auto vacuum analyze threshold for a table equal to number of tuples into auto vacuum analyze scale factor plus auto vacuum analyze threshold. So for that, let's say I have 1000 number of rows and auto vacuum analyze scale factor is 0.1 plus this is 50. So 100 plus 50 there are 150, let's say if there are 150 select operations or insert operations are going to happen, then the Postgres is going to run the analyze operation automatically. Simply auto vacuum has automated the process of vacuum and analyze operations. So when it is going to run, whenever the table reaches those thresholds, the auto vacuum launcher is going to launch this auto vacuum demand to perform this auto vacuum and auto analyze operations. How can we check when the auto vacuum and auto analyze operation has been happened? Again, the same table pg underscore stat underscore all underscore tables. Okay, now select schema name, rel name, comma, n underscore live underscore tup, comma, n underscore dead underscore tup, comma, last vacuum and last auto vacuum, last analyze, comma, last auto analyze from pg underscore stat underscore all underscore tables, where schema name equal to, what is the schema name here? Let me check. Demo. 1 minute. N underscore live. Okay, see. So, the schema name, relation name, live tuples, dead tuples, and all, Last vacuum, when you run the vacuum operation manually, this row will be updated. When the system runs the vacuum operation, then last auto vacuum row will be updated. When you run the analyze operation manually, then this column will be updated. When the system runs the analyze operation, then this will be updated. This is how it works. Okay, if someone asks you to how to check when the vacuum and operation has been opened, then if you run the vacuum operation manually, then the last underscore vacuum table will be updated. If the system runs the vacuum operation, then we call it as auto vacuum, and last auto vacuum column will be updated. If you run the analyze operation, then last analyze column will be updated. If the system runs the analyze operation, then last underscore auto analyze will be updated. So this is how, about vacuum operation, and this is about the concept of auto vacuuming in Postgres. This is very, very, very important topic. Okay, so that's it for today. Any doubts so far? Any doubts?
Yeah.
Yeah, sure, you're talking something. If you're talking on mute.
No doubts, no doubts.
Okay, that's it for today. We'll connect tomorrow and we will be discussing out the basics of performance tuning as a DBA, how we are going to troubleshoot whenever you get some, like whenever someone asking you like my query is taking time. So that tomorrow's class also very, very important. Try to join. Okay, thank you.